The speed of science moves more quickly in today's world thanks to partnerships with private industry. One example of this at the College of Veterinary Medicine is a collaboration between K-State's Dr. Jianfa Bai and a company called Integrated Nano-Technologies, or INT, to improve its portable chute-side diagnostic technology for detecting RNA viruses.
In the field, it's very difficult to detect pathogen directly. You have to send a sample into the lab and process in the lab before you get the results. And their device is kind of a battery-run portable handheld device. So in the field, you collect the sample and you process the sample and you detect at the same time.
INT's earlier prototypes had been designed to detect bacterial pathogens such as anthrax. The company pushed to expand their capability to use Bovine Virus Diarrhea Virus, or BVDV, as a model for detecting RNA viruses. In 2007, the company approached the College of Veterinary Medicine because of its expertise with BVDV.
But it quickly became, this could be a great opportunity for K-State to plug into some really interesting, cutting-edge technology that was being used with the Department of Defense, and taking it from that arena into a more practical arena and using the animal models that we might have here at Kansas State.
The instrument detects pathogens by denaturing or breaking down the genetic material found in collected samples. Then the material is hybridized or reconstructed on a specially designed microchip. When certain genetic material builds a bridge on the chip, it creates an electric current and allows the device to distinguish between a positive and a negative sample. The future design of the device will have the capability to detect and differentiate multiple pathogens. To adapt this technology to detect RNA, which is more fragile than the DNA found in bacteria, INT required the creation of an artificially designed single-strand DNA that mimics the characteristics of the BVDV, a task that Dr. Bai's lab was well suited for.
Instead of the days where we were looking at whole bugs and growing bugs, now we're looking at snippets and small pieces of genetic material that Dr. Bai is an excellent expert in that area, and bringing that technology to practicality can be a challenge sometimes, and this is an opportunity for him to plug into some really practical and exciting potential opportunities.
The device is still being tested, but once completed, it will be useful as a portable screening tool in remote areas without access to laboratory-based diagnostic tools. The creation and validation of new diagnostic equipment is one of the many benefits from this collaboration.
We as a university, and particularly for the diagnostic lab, our main target is to provide high-quality service, but we do not have the capacity to do in-depth research to develop a new technology for detection. So that's an advantage to collaborate with those companies. They are targeted to develop a new device or new machine so that it's more portable or cheaper.
This kind of a relationship is a bit of a model for us to learn how to work with the private sector, how to take high technology from both sides and blend it into a very useful application. It's an opportunity to learn from them and vice versa. And if the partnership is correct, put together correctly, then everybody wins.
Visit the Kansas State Veterinary Diagnostic Lab website to learn more about these services and research.